What unites three events separated by thousands of kilometers and years? Boeing, silence on the air, and one moment when metal decides who is in charge, a man or a machine. The year is 1991. Thailand. In the sky above the jungle, there is a sound like someone is chopping the air apart. A second later, there is a flash, and the night sky turns orange-red. This is Lauda Air Flight 004. There are 223 tons of metal, fuel, and people on board. An airplane designed for perfect harmony suddenly turns into chaos. But to understand why this happened, you need to go back to where it all started. Into a world of speed, risk, and control, where the smell of burnt rubber mixes with gasoline, and the human will fights with cars millimeters away from disaster. This is not a racetrack. This is the story of a man who survived the fire to create his own sky and see it crumble. The name is Niki Lauda, a man who didn't believe in randomness. In Formula One, he survived an accident where even the air didn't want to stay around. He came out of the fire, returned to the track, and became a symbol of the fact that a person is able to deceive fate. And then I decided that I could tame aviation. His company is Lauda Air, a small airline from Austria, but with the ambitions of a major player. On the fuselages is his last name, in red on white. Each flight is a reflection of his character, precision, pride, and control. He personally checked the details, diagrams, and reports. In the air, as well as on the track, there should be no doubt. And yet, one Boeing 767 was an exception. A small breakdown, an insignificant paper wording, and a strange coincidence all formed a chain where each detail was insignificant individually. But together, it became fatal. While the crew was carrying out the usual procedures, one parameter had already gone beyond the norm. The automatic mode was preparing to execute a command that no one had given. One of the engines was ready to reverse, not on the ground, as it should be, but in flight, at an altitude of 10 kilometers. After a few minutes, the silence of the cabin will be replaced by vibration, and vibration by loss of control. But for now, everything is calm. The commander is flying the plane, the passengers are drinking coffee, and there is a flat course line on the radars. This is the moment before a thunderstorm, when even the air freezes. Every disaster is not just a fall in technology. This is a clash of human confidence with what man himself has built. Lauda Air is not just an airline. It is a symbol of the fact that even someone who has defeated fate once cannot always defeat the system. When the engine roars at the start, time stops flowing. There is only momentum, speed, and cold logic inside the head. Niki Lauda has never been a typical racing driver. He wasn't aiming for fame. He was aiming for control. On the track, he was an engineer with a helmet. He calculated everything from the temperature of the tires to the angle of the curve on the asphalt. Error is not an option. In 1976, Lauda went through something that would have destroyed anyone else. His car burst into flames after hitting the barrier, fire, acrid smoke, dozens of seconds of struggle for breath. But he came back. 42 days after the accident, I went back to the start. In a bandage, with burns, but with the same icy look. He proved that a man can subdue even chaos. After Formula One, he was not looking for peace. The speed just changed shape. The sky became his new highway. In 1979, he created Lauda Air, an airline with a racer's philosophy. No compromises, no accidents, no maybe. Every detail must be verified. Every detail must be under control. He chose the type of aircraft himself, approved routes, and negotiated with Boeing. For him, the sky is the same track, but without the finish line. And instead of pit stops, there are airfields. Lauda Air started with charter flights, tourist destinations, leased planes, a modest logo. But Lauda's ambitions quickly went beyond that. He wanted his planes to fly where giants like Lufthansa fly, so that the passenger, seeing the Lauda Air logo, understands. This was done by a man who never gives in. He participated in negotiations with pilots, engineers, mechanics. He often appeared in the hangar, checking technical reports. If something seemed illogical to him, he would raise the issue. In aviation, as in racing, a little thing decides everything. And Niki knew that better than anyone. By the early 90s, Lauda Air had its own fleet of jetliners, Boeing 737 and 767. Modern machines, new engines, digital electronics, sophisticated control systems. Everything looked perfect, but it was precisely in this ideality that the trap was hidden. Lauda trusted the technique, but not completely. He often said, "An airplane is not God. He does exactly what he was programmed to do." That's why he always demanded of pilots not to rely blindly on automation, to understand what's going on inside the car. In May 1991, one of these Boeing 767s was preparing to take off from Bangkok. The flight commander is an experienced pilot. The second one has many years of experience. Everything is under control. Everything is on the checklist. But Lauda could not have known that this flight would be the moment when control would leave the cockpit. May 7th, 1991, Thailand. The night air is thick, like wet glass. In the parking lot of Bangkok Don Mueang Airport, an on-duty searchlight slides over the hull of a Boeing 767-3Z9ER, a twin-engine airliner with the tail number OYLAV. On the fuselage there is a red and white Lauda Air inscription. The plane is preparing for flight NG004 to Vienna via an intermediate landing in Bombay. The commander is Thomas Joseph Wells, 48, a former military pilot with more than 11,000 flight hours. The co-pilot is Ernst Kegel, 41, an experienced instructor. The cabin is in perfect order. Everyone knows what to do and does it calmly, without unnecessary words. They work in unison, like a Swiss machine. The temperature outside is plus 30 degrees Celsius. Humidity is below 90%. The air is heavy, but the Pratt & Whitney PW4060 engine will sound confident. The displays have stable parameters. The check of the reverse traction systems is carried out without deviations. No anomalies. Passengers take their seats. Among them are families, tourists, and business people. For them, this is an ordinary night flight. No one knows that in the next few minutes this aircraft will become one of the most discussed in the history of aviation. At 23:02 local time, the crew receives permission to take off. The commander takes the airliner to the runway. The headlights reflect off the wet concrete like a mirror. The co-pilot's voice is in the cockpit. V1 rotate. The steering wheel goes back on itself. The nose rises. The plane takes off from the runway. The city lights remain below, and beyond the porthole there is inky darkness. After climbing, it's routine. The crew turns off the landing lights and switches the engines to cruise mode. On autopilot, the course is west, 316 degrees. The cabin is quiet. Only the faint hiss of the radio and the occasional phrase from the dispatcher. Everything is going according to plan. But somewhere deep inside the systems, another process begins to live. The reverse control module has a component called directional control valve, which controls the hydraulic pressure. It is he who is responsible for ensuring that the reverse does not turn on in the air. And it is he who is now preparing to do something that should never happen. At an altitude of about 24,700 feet, the crew notices a strange thing, a slight fluctuation in thrust on the left engine. It's minor, like there's a malfunction in the sensor readings. A warning lights up on the screen: REV ISLN VAL, reverse isolation valve. Unknown message. None of the pilots had seen him before. The commander scrolls through the instructions, looking for the procedure. There is no such signal in the manual. Boeing did not envisage that it could appear in flight. After a short discussion, they decide, sensor error. The system is overheated, we need to monitor it. After a few minutes, the co-pilot notices a slight tremor of the thrust control lever. He doesn't move, but he seems to be living his own life, barely trembling. The commander tenses up, looks at the pressure display. Everything is fine. Then a quiet phrase sounds, almost in a whisper, but with anxiety that the passengers will not hear. It seems that the reverse is on. When an airplane lands, its engines don't just slow down, they change the direction of flow. The blades inside the engine unfold, and the jet of air goes forward, braking the car. This is thrust reversal, a powerful system that allows you to stop a liner weighing hundreds of tons in a matter of seconds. But in the air, reverse is the enemy. Turning it on at speeds over 500 kilometers per hour destroys the balance of aerodynamics. One engine starts to slow down the aircraft, the second one continues to pull forward. The difference in thrust turns the liner into an uncontrollable boom. The air that should flow around the wings suddenly breaks the flow. And that's it, the end of manageability. The Boeing manufacturer assured, the design excludes the inclusion of reverse in flight. This is physically impossible. Electronic interlocks, hydraulic valves, duplication of systems, everything is thought out. In theory. But that very night, the theory stopped working on Thailand. The REV ISLN VAL signal was a warning. The hydraulic valve, which was supposed to remain closed, gave way. A small spring, about the size of a fingernail, could not hold the pressure. And now the left turbine of the Boeing 767 was waiting for only one thing: the command to deploy thrust. The commander and co-pilot continue to monitor the readings. The plane is gaining altitude. The autopilot is stable. Passengers don't feel anything. But the system is already armed. All you need is an impulse. At 24,700 feet, at a speed of about 780 kilometers per hour, an instantaneous event occurs that will change everything. At one point, the reverse circuit opens in the hydraulic line of the left engine. Flap rotation, gas pressure, impact. The airliner jerks to the left, as if someone hit the wing with a giant hammer. The autopilot turns off. The co-pilot pulls the steering wheel, and the angle of attack increases. The air won't work. The engine is roaring at maximum speed, but now it's against the direction of flight. The reverse has really turned on. For the first time in history, in flight. A moment that shouldn't have happened according to any instructions or in any textbook. All that remained was to try to save the car, which physics had already released. The first second is a left kick. The plane tilts sharply nose down. The automatic system shuts down, and the autopilot disconnect. Alarm sounds in the cabin. The commander immediately pulls the steering wheel towards himself, but the left wing is already losing lift. The second, the load on the case increases. The vibration goes through the floor. The steering wheel trembles like a taut string. The co-pilot gives the command. I'm closing the left engine. It reduces the fuel supply, but the reverse is already physically activated. The flaps block the flow, and the thrust turns into a brake. Third, the asymmetry begins. The right engine pulls forward, the left one pulls back. The plane literally turns out in the air. The crew is trying to balance the roll. Pedals, steering wheel, throttle. At an altitude of 7,600 meters, they can still fight, but the aerodynamics are already crumbling. Fourth, the overload is increasing. The indicators crackle from pressure surges. The deformation of the wing is recorded on the external cameras. The air hits the hull, creating a roar similar to the roar of a jet wind. Fifth, the pilots decide to turn off the power to the left engine. The commander speaks briefly. Cut fuel. But the system does not react instantly. The pressure inside the circuit does not drop. The reverse continues to work, as if someone turned on the brakes at a speed of 830 kilometers per hour. Seventh, the plane tilts at a 25 degrees downward angle. The dive begins. The air hums, the dashboard vibrates. The co-pilot squeezes the steering wheel so that the joints turn white. The 10th is that the overload exceeds 3G. The cabin becomes an arena of struggle. The force of inertia presses on the bodies. The chairs creak. The commander tries the stabilizer. The reaction is minimal. 15th, they are trying to align the liner through the thrust of the right engine, reducing the speed to reduce the roll. But the loss of speed does not bring balance. Now the liner is falling almost vertically. The 20th, the indicators light up one after the other. Hydraulic fail, stabilizer limit, overspeed. The plane is no longer flying. It is spinning. The wind cuts the air. The hum becomes a solid background. 27th, overload reaches critical. The metal can't stand it. The tail sections are the first to be surrendered. The fuselage's power elements are ruptured. The skin begins to come off in waves, like paper. The 29th is the last phrase in the cockpit. The commander's voice, heavy and strangled. God, the speed is too high. Then silence. The NG004 flight marker disappears on the dispatcher's radar screens. There are only 29 seconds between turning on the reverse gear and the plane disappearing. Below is the dense jungle of Western Thailand, and a flash that will light up the sky for a second longer than the entire flight lasted after the crash. The night seemed to freeze over Western Thailand. Humid air, heavy clouds, rare sounds of insects and distant engines. And suddenly, a flash. First white, then scarlet orange, as if a portal of flame had been opened in the sky. The The commander of another plane nearby would later say, "I saw a huge fireball falling rapidly, almost vertically. The trail followed him like a rocket." It was a Lauda Air Boeing 767. When the hull reached a speed of over 900 kilometers per hour, the skin could not stand it. The metal was bursting like cloth. The tail separated first. An aerodynamic explosion tore it right at the base. Then the engines broke off. The wing panels flew apart. The plane disintegrated in the air. The debris fell over an area of just over a kilometer. Burning fragments pierced through the foliage, flared up on the ground, creating the illusion of many bonfires. That night in the Fufafak area was visible even from the nearby hills. A few hours later, the search began, but it was almost impossible to get to the place. The jungle was dense, with no roads. In the morning, when the heat rose above 30 degrees, helicopters found black spots on the green carpet of trees. For those who arrived on Earth, a scene of chaos opened up. The remains of the fuselage, curved beams, fragments of seats. Humidity is below 90%. Thick smell of fuel, soot. People gathered from local residents helped to look for at least something useful: documents, devices, system blocks. But there was also something that they tried not to talk about later. Some rescuers saw how volunteers from local villages cut off jewelry, took purses, and pulled everything that glitters. Not out of anger, but out of poverty. That night divided the sky into before and after. Austria found out about it this morning. News feeds: Lauda Air Boeing 767 lost in Thailand. Reporters were waiting for a comment. And a few hours later, he appeared at Bangkok airport. The man whose name was on board the plane. Niki Lauda. No press service, no security. He flew in by himself. Straight from Vienna to see what's left. He walked through the charred wreckage in a white shirt, in silence. It wasn't just a flight for him. It was his company's plane, named after him. The flames over the jungle went out quickly, but the effects did not fade for years. It was the worst disaster in the history of Austrian civil aviation. And no one understood then what really happened. The world saw only fire. But the real reason was hidden inside steel valves, hydraulic systems, and papers where signatures were worth more than a human life. The morning after the disaster. The jungle smells of kerosene and wet earth. Thai military helicopters are circling over the crash site, and tables with numbers are placed on the ground under canopies. The found parts are stacked on them. The main goal is to find the black boxes. One of them, a CVR voice recorder, was found 2 days later. The case is fused, but the magnetic tape has survived. The second one, the FDR, with flight parameters, is completely destroyed. All the digital data that could explain why the reverse was turned on has disappeared. Only the audio recording of the last minutes remains. It shows calm voices, short commands, and then a dull pop, an alarm, and a sharp noise that turns into a roar. The commander's last words: "God, the speed is too fast." Niki Lauda was present at the scene of the investigation personally. He did not stand aside, did not give interviews, just watched. There was no emotion in his gaze, only cold concentration. He listened to the engineers, asked questions, and demanded diagrams, photos, and maintenance logs. When the Thai Commission presented the first conclusions, they sounded simple: turning on the reverse thrust of the left engine in flight. The reason is unknown. There were no culprits in the report, just the facts. But Lauda did not accept it. He knew that there is no just like that in aviation. Every deviation is someone's flaw, miscalculation, or deliberate disregard of the rules. He believed that the plane could not just decide to turn on reverse. So there must be a mistake somewhere. At that time, there were hundreds of Boeing 767s flying in the world. And if it was a technical vulnerability, it means thousands of lives are at risk. Lauda understood that the matter went far beyond the scope of a single airline. He called a press conference, where he said a phrase that became iconic: "If the manufacturer is sure that the aircraft is safe, let him prove it in the air." Pilot, world champion, owner of the company. He challenged Boeing. The Americans reacted cautiously. They promised to figure it out, but in a few months, it was just another incident for them. For Lauda, it's a personal betrayal. He bought their plane, trusted their system, their people, and now his name is on all the newspaper covers next to the word disaster. A week after the press conference, Lauda flies to Seattle, to the Boeing headquarters. Engineers, lawyers, and journalists are with him. He demands to conduct a test, to turn on the reverse on the simulator in the same conditions as on the night of the disaster. In the simulator room, Lauda sits at the helm. Several cameras are recording what is happening. Launch, takeoff, climb. And at the right moment, he manually activates the reverse of the left engine. The result is instant. The plane turns around, loses control, and crashes. He tries again, the second time, third, 15 attempts, and it's the same thing every time. After the last cycle, he gets up, looks at the Boeing engineers, and says quietly, "You saw it. It's not a pilot's mistake." There was silence in the air after the Seattle tests. Niki Lauda showed what no one wanted to see. The plane, certified as safe, could not be controlled when the reverse was turned on. 15 attempts means 0 chances to save the liner. Even in ideal laboratory conditions, with the readiness to maneuver, with the perfect reaction of the pilot. Journalists filled the hall, cameras clicked, but Boeing was silent. Their representatives avoided direct answers. The official position sounded neat. Additional checks are needed. To Lauda, it sounded like a mockery. He was a racing driver. He knew the value of seconds. In the world of aviation, those seconds were worth hundreds of lives. Then he went all in. I called a press conference in Vienna. Cameras, lights, dozens of microphones. And Lauda, standing at the podium, without a jacket, in a shirt, with eyes that no longer left any doubt. I demand to be given a real plane. The real 767. I'll turn on the reverse in flight and show you all how it ends. This phrase has spread all over the world. Newspaper headlines said, Niki Lauda challenges Boeing. He was called a madman, a hero, a control freak. But there was a simple logic behind it. If the system was faulty, then someone had to fix it. Boeing could not ignore this wave. An emergency meeting was held in Washington with the participation of engineers, representatives of the FAA, and the Federal Aviation Administration. The commission was supposed to check all 767 airliners flying around the world. And only then did the American corporation admit that during the certification tests, the reverse was indeed activated, but under different conditions. The speed is about 370 kilometers per hour. The altitude is 3,000 meters. Much less than Lauda Air had at the time of the crash. In other words, the tests were conducted not in the critical range, but in safe modes. The official Boeing report stated, turning on the reverse at high speeds does not pose a threat to flight stability. These words were signed, sent to the regulator, and no one else checked. Now the whole world knew that this phrase had cost the lives of 200 people. Boeing understood that admitting a mistake meant admitting responsibility, and millions of dollars in lawsuits. Therefore, in the first months after the disaster, the company took a defensive position. They promised to release a statement in 3 months. But time passed, and there was no statement. Meanwhile, Lauda was becoming a symbol. On the TV news, he was shown not as a businessman, but as a man who was fighting against a corporation. His demand was simple: state the reason. Prove that it won't happen again. Under public pressure, Boeing nevertheless began its own tests. On simulators, in wind tunnels, with digital modeling. The result turned out to be the same. When the reverse is activated at high speed, control is lost in seconds. It was a shock for the corporation. For Lauda, this is a confirmation of the obvious. But the truth came at a cost. Lauda Air's reputation was already under attack. The press wrote, the crash of the racer's plane, crew error, reverse problem? No one knew for sure. Lauda did not back down. He personally participated in the commission's meetings, insisted on an open investigation, and secured access to Boeing data and engineering journals. He was interested in one question: how could a system designed for safety destroy an airplane? The answer was hidden in the documents, where the numbers did not match reality, where engineers substituted math for tests, where, instead of checking at height, a calculation model is used. The papers were perfect, as always. Only the plane is not. In aviation, paper is sometimes stronger than titanium. The certificate, the signature, the seal, and the liner gets the right to fly, even if no one has tested it in the conditions where it will actually work. The investigation, launched after pressure from Lauda, revealed an unpleasant truth. During the certification tests of the Boeing 767, engineers tested the thrust reversal system not at 500 to 800 kilometers per hour, but at 370 kilometers per hour and at an altitude of only 3,000 meters. It was a safe window where aerodynamics forgives mistakes, where the plane is still docile. But in a real Lauda Air flight, the reverse was turned on at 24,700 feet, almost 8 kilometers, and at cruising speed. Under these conditions, all the assumptions from the FAA documentation, the U.S. Federal Aviation Administration, simply did not work. Boeing handed over the results of the safe tests to the regulator, and then a formula familiar to all engineers came into play. The data is extrapolated. That is, the real figures were simply multiplied by the coefficient. Without verification, without repeated modeling. Paper, everything came together. In practice, the liner turned into an uncontrolled object if the reverse was activated at altitude. This is how the system was approved for operation. And no one asked any more questions. When Lauda saw a copy of this report, he couldn't help himself. The paper, signed by dozens of experts, has become a symbol of how human self-confidence kills accuracy. He said briefly, "They certified the hypothesis, not the plane." And that was no exaggeration. The FAA later admitted that the certification basis did not take into account the aerodynamic features of new wide-body aircraft with short engine pylons extended forward from the wing. At speeds above 700 kilometers per hour, the reverse jet did not strike downwards, as expected, but upwards, directly into the stream above the wing, destroying the lifting force. What was considered a minor engineering detail turned out to be a fatal scheme. It's beautiful in the laboratory. It's deadly in the sky. But the fault was not limited to the American corporation. When the commission got to the Lauda Air maintenance logs, new questions began. The reverse failure was recorded 13 times in the 9 months before the disaster. Each time, the engineers changed the valves, reset the errors, and launched the aircraft back into flight. The EEC maintenance message error, a signal indicating a problem in the electronic engine controller, appeared over and over again. According to the regulations, you can fly with it for a maximum of 500 hours. Lauda Air simply restarted the meter. In fact, the plane flew with this error for more than 1,800 hours. Technically, it's not a violation. The paper allowed it. The real thing is the accumulation of risk. And when the valve gave up, it worked exactly as every engineer feared, accidentally, in the air. Boeing was silent. The FAA did not comment. And Lauda said on camera, "They built a system where responsibility is lost between the pages of the report." He was right. No company wanted to admit that documentation was more important than reality. But now it wasn't the name of the racer that was at stake, but the credibility of the entire civil aviation industry. Lauda Air's engineers worked with precision, but under constant schedule pressure. Every flight is money. Every idle flight is a loss. In an airline with a limited fleet, each car must fly almost nonstop. That is why technical failures did not cause panic. They were simply eliminated on the spot. The technical logs of the Boeing 767 with the tail number OELAV recorded 13 entries about interference with the reverse system 9 months before the crash. Always the same left engine. Sometimes the message is REV ISLN VAL, sometimes EC maintenance. Every time, pressure relief, valve cleaning, electrical check. The reason was repeated, sticking of the reverse control valve. The engineers suspected moisture, corrosion, or microcracks in the hull. Replacing parts helped for a while, but after a few dozen hours of flight, the signal returned. According to Boeing regulations, in case of repeated errors of this type, it is necessary to contact the manufacturer directly, suspend engine operation, and conduct an in-depth analysis. But Lauda Air could not afford to take the plane out of the schedule. The official explanation is the defect does not affect flight safety. That's what they wrote in the magazines after each check. The wording is familiar to any engineer, a minor deviation allowed for flights. The plane continued to fly, and the time counter was running. According to the instructions, if the EEC maintenance message error persists for more than 500 hours, the aircraft must be removed from the line. On OELAV, this mark was simply reset. The numbers were reset to 0, and the car was on its way again. When the commission raised these records, it became clear that there was a typical culture of compromise within the company. Not negligence, but the habit of making it to the next flight. This is what many airlines do when a defect does not pose a direct threat. Only here this defect was in a system that should be dead in the air. During one of the checks, an engineer by the name of Gottlieb wrote in a report, "During the test, there is a slow response to closing the reverse. The cause has not been determined. The valve has been replaced. The test is passed. No additional measures. No flight ban. Everything was decided under the signature, and the paper made the plane serviceable again." There was an unspoken phrase inside the technical service. If the signal has disappeared, then the plane is healthy. No one thought that the signal disappears not because the defect has been fixed, but because the system does not have time to track it. The same philosophy has become fatal. Boeing accused Lauda Air engineers of improper procedures. Lauda Air is a manufacturer in a substandard system, but the truth turned out to be between them. The two sides are used to trusting paper more than the device's display. When Niki Lauda read the internal reports, he did not defend his own technicians. He just said, if at least one person knew that the valve was not perfect, it was already a crime. This phrase has become a symbol of the gap between engineers on the ground and pilots in the air. Those who serviced the plane believed in the instructions. Those at the helm believed in the system. But no one saw that it was already cracking from the inside. After the investigation became public, Boeing could no longer pretend that nothing had happened. Under pressure from the press, the Austrian authorities, and Lauda himself, the corporation announced a large-scale revision of the entire Boeing 767 series. The first solution is to replace the reverse hydraulic valve on all aircraft with the same type of Pratt and Whitney PW4000 engines. The second is to add a pressure sensor to the system so that the crew can see if the reverse is ready for activation, and so that the automation can block activation if the aircraft does not touch the ground. Boeing has issued a bulletin marked Urgent Execution. In 6 months, more than 1,600 aircraft have been upgraded worldwide. In engineering circles, this was called a tacit admission. No one officially talked about the manufacturer's fault, but the changes spoke for themselves. The Commission's report, published 8 months after the disaster, contained a key phrase. The cause of the crash was the unauthorized activation of the left engine thrust reversal. The probable cause of activation is a hydraulic valve failure. Boeing and the FAA added the wording. The exact cause of the failure has not been determined. No names, no punishments. Only a careful admission that the system could behave unpredictably. For Lauda Air, this meant the end of tranquility. A wave of lawsuits began. Relatives of the passengers filed applications to the courts of Austria, Thailand, and the United States. Insurance companies demanded millions. The reputation collapsed. Niki Lauda did something that an airline owner rarely does. He left his office and personally answered questions from journalists. He spoke openly, without PR. "I was responsible to every passenger who boarded this plane. I wasn't in the cockpit, but it was my car, and my last name is on board. It's my duty to find out the truth." He didn't shift the blame. Boeing, engineers, regulators, and technicians were all part of the same chain, where each mistake reinforced the next. A year later, Lauda leaves the post of CEO of his own company, not because of bankruptcy, but because of principle. He understood that trust in the brand under his name could not be restored. He remains only a member of the board of directors, and in December 2000 Lauda Air officially became a subsidiary of Austrian Airlines. But Lauda did not leave aviation. In 2003, he created a new airline, Niki, then Lauda Motion, and rebuilt the business with a different approach. Without loud slogans, without fanaticism of control, but with the same attention to detail. Until the end of his life, he remained a man who did not allow himself to forget. After the disaster, he often repeated, "Security is not about equipment. It's a culture of thinking." This disaster changed not only the Austrian aviation industry, but the entire industry. After that, new points were added to the certification of Boeing and Airbus. Now every system that affects control must be tested in real flight conditions, and not just on simulators. Hundreds of lives were saved later precisely because one man refused to remain silent. Lauda Air no longer existed as a brand. But the name on board that plane has always remained a reminder. No paper can be more important than reality. When Lauda left his own company, many people thought it was the end of the story. The driver lost the battle not with the car, but with the system. But for him, defeat was always just an intermediate round. He didn't know how to stop until he'd perfected everything. 2 years after leaving Lauda Air, he returned to the skies again, but under a different name. Niki Luftfahrt, an airline with a simple and proud name, became his new attempt to prove that aviation can be honest. Without loud promises, without bureaucracy, with transparent processes and direct flights. He chose the planes personally again. This time it's an Airbus A320, European technology, a different approach, a different mentality. He trusted Airbus because he saw that after the Lauda Air disaster, it was Boeing's competitors who drew conclusions. They revised the reverse system, added physical locks, and changed the test standards. Niki quickly became recognizable. The logo in the form of a lowercase signature is simple, concise, and without pathos. For Lauda, this was not a business story, but a personal therapy. He could stand in the hangar again, check the cockpit, talk to the pilots. Not as a boss, but as a colleague. In 2011, the company entered into an alliance with Air Berlin, then went through mergers and crises, but held on. Lauda flew again, sometimes incognito, just to get a feel for how the system worked. He sat in the co-pilot's seat, watched the young commanders work with automation, and sometimes quietly corrected. Never trust a car more than yourself. When Niki went bankrupt in 2017 due to the problems of Air Berlin, it did not stop again. A few months later, he created Lauda Motion, his third project, his third attempt. The same philosophy, but in new realities. A low-cost model, cooperation with Ryanair, cheap tickets, but strict safety standards. Once again, he personally participated in the certification, monitored reports, and interfered with contracts. He was known as a man who could call an engineer at 3 in the morning and ask, "Why didn't the valve get replaced?" In 2019, Lauda Motion was completely taken over by Ryanair, but Lauda remained an advisor. He still went to the hangars, sometimes appeared in the cockpit, discussed routes. His life was in a circle: speed, control, responsibility. Formula One gave him the survival instinct. Aviation gave him the meaning. He often said, "The problem is not the cars. The problem is with people who think they're perfect." These words have become a credo for an entire generation of pilots. Niki Lauda lived the life of a man who didn't know how to be a spectator. After the Lauda Air disaster, he could have left, closed down, disappeared from the news. But instead, he built new planes and new people who flew them. When a plane with red and white accents and the word Lauda on the fuselage appears in the sky today, it is not just a brand. This is the signature of a man who spent his whole life trying to make heaven honest. The Lauda Air disaster was a rare case when mistakes were not hidden under reports, but turned into reforms. After the investigation, engineers and regulators around the world began to review what had previously been considered unshakable. The first change concerned the certification of reverse systems. Previously, they were tested in conditions close to landing conditions: low speed, low altitude, minimal overloads. Now, only in the real flight profile, at cruising speed, and at an altitude of up to 10 kilometers. This requirement was introduced not only by the FAA, but also by the European EASA, making it mandatory for all manufacturers. Boeing has improved not only the 767. All new models have multi-level protection, mechanical locking of the reverse flaps, electronic confirmation of landing gear touch, and an algorithm that compares data from 3 systems at once: pressure, rack position, and engine power. If at least one parameter does not match, the reverse simply will not turn on. New procedures have been introduced for pilots. The checklists now include the item uncommon reverse, unintentional activation of reverse. A situation that was previously considered impossible has become mandatory for practice on the simulator. The service centers have changed the logic of accounting for technical errors. If the EEC maintenance session message appears 3 times, the aircraft automatically leaves for diagnostics, regardless of the schedule. You can't reset the timer now. The system records flight hours and blocks departure when the limit is exceeded. These were not just technical innovations. It was a confession: even a perfect technique must be tested against human overconfidence. After Lauda Air, engineers began to treat the word unlikely differently. Now every unlikely event was analyzed as a potential one. The test standards have changed for both Airbus and Embraer, and even for military aircraft. New cases have been added to airline training centers. On the screens of the simulators is a Boeing 767 Lauda Air model. with the inclusion of reverse in the air. The instructor explains how to react. Reduce the thrust of the second engine, hold the steering wheel, do not try to level the plane instantly. For pilots undergoing training today, this case is simply referred to as Lauda scenario. The Boeing factories changed their certification philosophy after 1991. Now it is impossible to extrapolate the data without a real test. No number should exist without an experiment. Even decades later, engineers call the Lauda Air disaster a lesson that taught us not to trust schedules. Ironically, it was a technical disaster that made aviation more humane. The sky became a little safer, not because someone came up with new materials, but because one person refused to accept the wording, "This cannot be." There is an old piece of metal at the airfield near Vienna, a fragment of the Boeing 767 skin. It has a faded inscription, Lauda Air. For most, it's just an exhibit. For those who know the story, it is a reminder of how 1 second can change everything. This disaster did not leave heroes and villains. Only people who believed in the system, and those who once realized that the systems were wrong. Niki Lauda was not perfect. He could be tough, stubborn, and sometimes harsh. But it was this stubbornness that forced aviation to face the truth. He did not allow the tragedy to be turned into a dry report. His persistence brought the problem to a level where decisions were no longer made by managers, but by engineers. Years after the disaster, he said in an interview a simple phrase: "We could lose the race, but we have no right to lose the truth." And it was not a metaphor, because it is the truth, not paper, not corporate, but human, that saves those who rise into the air. More than 30 years have passed since then. Boeing 767s are still flying, but now each of their systems knows the cost of this mistake. No reverse is activated in flight anymore. No valve is left unchecked. Aviators call such cases turning points. After them, the industry is never the same. The Lauda Air disaster was one of them. Today, when the plane touches the runway, passengers feel a jerk. It turns on the reverse thrust. It's a common occurrence, dozens of times a day. But behind that moment, there are decades of work, testing, and improvement. And the memory of those who once paid too high a price for a mistake in one line of a document. There is no past in the sky. There is only experience turned into safety. And in every landing, where the plane slows down gently and calmly, there is a part of that second when everything went wrong. The second that changed the sky forever.